this bending experiment is concerned, mold point, setback, bend allowance, K factor and bend direction. Okay, these terms are very important. So here you have been given raw material. Started development. Okay. So this is 92 and this is 20 mm width and thickness is 3 mm. Right? Now let us discuss what is mold point, what is setback and bend allowance. And the radius, as per our drawing, this radius is, I think they have given 10 mm. Dia 10. The radius what you have to obtain here is 10 mm. This is 10 mm. Okay. So now, what is this mold point? We'll see. So this is the mold point. Mold point. Mold point. This point is mold point where the bend takes place. Is the mold point where the bend gets initiated. Now coming to what is setback. So this is one of the important term which is used. So here I will explain. Okay. So this is the radius or diameter which is given for us, that is 10 mm radius or 10, so dia 10. And now this is your neutral axis. This is neutral axis. Neutral axis. This is your neutral axis of the given strip. And now what is setback? Setback equal to, how setback is calculated? Now this is the radius from this end and this is the radius from this end. Setback is equal to bent radius plus half of the thickness of the metal or metal piece. So this is the radius. Listen carefully. This is the radius which we need to form, or bent radius exactly, and this is the neutral axis. Right? Now setback term is defined as bent radius plus half of the thickness of the material. Half of the material thickness. So this is bent radius, and this is material thickness. Okay. Now when coming to this neutral axis, so the radius or the perimeter, I say, meter about neutral axis is equal to, I am considering about the neutral axis entire circle. That is, what is the perimeter? 2 pi into r. What is total r? Br plus half of material thickness. So this is entire for perimeter for entire circle, but we are interested to have only a quadrant portion. This portion we are interested. So now what I do, for quadrant portion perimeter is 2 pi by 4 into Br plus half of the material thickness. So this is what is how we calculate the bend allowance. Bend allowance. BA. Bend allowance. This is very important. Bend allowance. There are so other formulae linked up. So now to have this bend allowance, don't get confused. Setback. Setback is Br plus bend radius plus half of the material thickness about the neutral axis. I have shown you neutral axis here. Now, how to calculate bend allowance? Bend allowance for any material. For any material, you can calculate. This is a standard procedure for obtaining formula for bend allowance. Perimeter about the neutral axis is 2 pi r. So here total r is setback Br plus half of the material thickness. Now we are interested to have bend only in quadrant portion. It is 1/4 of circle. So for quadrant portion, by 4 I have taken. This is total perimeter for total circle, but we are focusing on only a quadrant. 2 pi by 4 into Br plus half of mt. So this, after simplification, how it comes? Just look at this. So 2 pi Br by 4 plus 2 pi by 4 into half of the material thickness. So hope now these two gets cancelled. This is 2. So pi by 2 Br. Pi by 2 Br, that is 3.14 by 2. 3.14 by 2 Br plus this is pi by 4 material thickness. So what is that we are calculating? We are calculating bending allowance. So this becomes 1.3 1 to 1 jar 1 1.5 1.5 Br or 1.57 it comes. 1.7 bent radius plus this is pi by 4. I think 7 point, 1 second, exactly the I read the value. 0.785. This is 0.785. 1.57 and 0.785 material thickness. So bend allowance is equal to 1.58. Bend allowance is equal to 1.57 bend radius plus 0.785 material thickness.